So he will be here like for 2-3 years.
2 years.
He did his PhD at the University of Palermo, and in 2024 he got a diploma. And before that, he was in Chicago, at the University of Chicago, for his master's. He has previous to this appointment, postdoctoral fellow at Mary's University in Canada. And today he will talk about X-ray high spectral resolution view of ultra-fast outflows in AGN.
Okay. Hello, everyone. I'm Yerong Xu. Very thanks for the introduction. And I'm the junior postdoc fellow at this institute, and very glad to take this opportunity to introduce my research with my colleagues. So today I will talk about X-ray high spectral resolution view of ultra-fast outflows in active galactic nuclei, with the focus on the case study PDS 456. My talk consists of 2 parts. First of all, I will give an overview of the ultra-fast outflows in active galactic nuclei, and then I will report some insights into ultra-fast outflows brought by the recently launched X-ray mission XRISM. So let's start from the very basic knowledge. I think most of you are already very familiar. Let me start from this point. The system we are interested in are the active galactic nuclei called AGN, and which are powered by the accretion onto supermassive black holes in the nearly every center of galaxy in the universe. So here is a schematic plot of AGN system consisting of a central supermassive black hole, an accretion disk surrounded, and a dusty torus structure. Also have the broad line region and diffuse narrow line region. In some AGN, that they also have the collimated jet, which could contribute to the strong radio emission. But today I will focus on the X-ray view of AGN system, because it will allow us to plot the very in the central region of this system. And the X-ray emission of AGN mainly originates from the comptonization of the hot plasma very close to the supermassive black hole. We call it hot corona. And why AGN are so important? Here is the famous M-sigma relationship, showing that the mass of the supermassive black hole at the center of galaxy are tightly correlated with the dispersion velocity of their host galaxy, suggesting that the growth of the black hole appears to be synchronized to that of the host galaxies, even if they have nearly 9 orders of magnitude difference in the spatial scale. So how can we explain this? The mechanism which is called AGN feedback were proposed to explain it. The idea is like in this picture, starting from the very inner region, from the supermassive black hole, it drives the outflows from the micro, meso, and macro scales, from the central engine to the host galaxy, and then into the interstellar medium, and then these materials could also go back for the feeding. So all the parts in these pictures could, like the galaxy, black holes, stars, and interstellar medium, to build up a thorough ecosystem. So this is the feeding and the feedback process are closed into over the cosmic time scale. But this scenario is very ambitious and very challenging to understand, because we need to consider the multi-scales and the multi-phase physics in both theoretical simulations and observations. But still, it's a very beautiful scenario. And here you can find some beautiful pictures from the observations showing the multi-scales and the multi-phase outflows detected in the AGN system, like from the very central region to the galaxy scale, and then into the intra-cluster scales. And the best way to explore the outflows in these different scales is to use X-ray observations to study the innermost outflows, and then use the optical or UV data for the galaxy scale outflows. And At the larger scales, we can use optical or the radio data to study them, because the materials, when they get out, they become less ionized. But today I will focus on this X-ray beam and to study the highly ionized outflows in agent. Here is the schematic plot showing you the outflows could be detected in the X-ray band of agent systems, and including the warm absorbers and ultra-fast outflows. We call it UFOs. According to theoretical simulations, like the outflows in agents with a kinetic energy larger than 0.5% adenine luminosity could be effectively drive the agent feedback by quenching the sublimation rate and reducing the black hole growth. That's why we are particularly interested in UFOs, because UFOs, according to the classical classifications, they have the outflows with a velocity larger than 10,000 kilometers per second, and they are usually highly ionized. So such extreme properties allows UFOs to carry away a huge amount of kinetic energy, which might be sufficient to drive the agent feedback. UFOs are usually, in general, UFOs are detected in the X-ray, detected through the strongly blue-shifted absorption features in the X-ray spectrum. Here is when they are intersecting with our line sight. Here is a typical UFO detection in the hard X-ray spectrum of the Quasar PDX 456. I will give more details descriptions later, but you can see the profile marked by the green line here is called P-Sigma profile, while the emission part originates from the scattering emission of those outflows misaligned with our line sight. So in addition, UFOs are not only detected in the hard X-ray bands, they could also be detected in the soft X-ray bands. Over the past 2 decades, UFOs have been detected in more than 100 UFOs have been detected in agent. And so when we're modeling the UFOs, these UFOs, 4 parameters could usually be used to characterize the outflows, including the ionization parameter, current density, turbulence velocity, and outflow velocity. And here the ionization parameter could see depends on the ionizing in luminosity, number density, and the distance to the X-ray source. And in 2013, Francesco Tombesi discovered, by modeling these agent outflows, he discovered very strong correlations between the pairs of these parameters of the UFOs and the warm absorber, like these two parameter panels plans shows. So they proposed a scenario to explain these correlations, that probably the UFOs and the warm absorbers are just the different parts of the same stratified outflows at different locations, while the UFOs were launched from the inner accretion disk, but the warm absorbers were detected at the distant places. However, when we're including the soft X-ray UFOs, that correlation breaks down, because those soft X-ray UFOs occupy the upper left corner in these parameter planes, and you can see they still keep the relativist velocities, but have the relatively lower ionization parameter and current density. Therefore, a more sophisticated scenario was proposed to explain this kind of UFOs. We call it entrained UFOs. That the idea is like the cold, clumpy interstellar medium could be entrained by the typical highly ionized UFOs from the inner accretion disk, and then during their propagation. So that's why they could have such a high velocity, but much cooler. So this kind of UFOs could work as an intermediate state between the typical UFOs and the warm absorbers. However, with their relationships still have not been real confirmed. It's still an open question. And yeah, given by the UFOs' extreme properties, we could estimate their kinetic energy. Based on these 2 formulas, we could estimate the kinetic energy of the agent outflow. here is the diagram comparing the UFO and warm absorber wind powers. And the blue points representing the UFOs, you can see they are more powerful than the warm absorbers, and nearly all of them are above the threshold for the Asian feedback. So that means the UFOs are powerful enough to affect the evolution of their host galaxy. And when we compare the UFO power with the other the outflows detected in the other wavelengths, as the right plot shows, the UFOs were represented by these red points on the right. And you can see UFOs still have the comparable kinetic energy with those galaxy scale outflows, such as the ionized winds or the molecular gas. So that means UFOs launched from the inner region of Asia are very promising to drive the galaxy scale, large-scale outflows, which is a very interesting component. And another interesting behavior about UFOs is their correlations with the accretions, because due to their relativistic velocities, we would expect UFOs launched from the accretion disk. So they may have some correlations with the accretion flows around supermassive black holes. So in 2017, Michael Parker had discovered a very distinct anti-correlation between the UFO absorption line intensity and the hard X-ray flux. And as the right plot shows, and the left shows you the three stacked spectrum at different flux levels, where you can find the UFO absorption feature is very strong when it's very significant when the source is at the lowest luminosity, but the UFO detection becomes weaker when the source gets brighter. So this anti-correlation means that the UFOs could respond to the variations in the source continuum change. So this is very interesting because usually we expect the hard X-ray flux in Asian originate from the hot corona with the size around 10 gravitational radii, but UFOs are expected to be launched from the regions larger than 100 gravitational radii. So that means this anti-correlation means that the physical process occurring at different scales, they could be correlated. Besides these correlations, UFOs, as you can expect, since it's come from the very inner region of Asia, they could show the very strong variability on different time scales. For example, like on the short time scales from the hours to days, as I mentioned and presented in the previous slide, UFOs could rapidly respond to the continued variations. So that will leave the excess variabilities in the RMS spectrum, as the left two example shows, illustrated by these multiple spikes. That's and the position of these spikes corresponding to the UFO absorption features, and this could be a very powerful and model-independent diagnostic for the UFO detection. And then, on the other hand, on the longer time scale, from the weeks to years, the right two examples show you that the UFOs could appear or disappear within weeks to years. So this is a very interesting property which allows us to constrain the number density and the location of these outflows. But this is also an annoying property for the astronomers, those who want to write the X-ray observation proposals to study UFOs, because nearly every proposals need to justify what if your observation cannot detect the UFO. So it's a very useful but still annoying properties for us. Another property is to make the despite we have detected many UFOs in the past 2 decades, we still don't quite understand what's the underlying mechanism for the UFOs. One promising theory is a radiation-driven outflow, where the wings are launched and accelerated by the strong radiation pressure, so they could be expected to exist in the high accretion system. Here, the high accretion means the adenine ratio larger than 0.1. And the lab simulation shows that UFOs could indeed exist in the super adenine agent systems and tend to be the equatorial direction. Another promising theory is magnetically driven outflows, where the winds are launched and accelerated along the magnetic field lines, like the right simulation shows, tend to be the polar direction. This mechanism is expected to be dominant in the low adenine agent, like some galaxies or the low luminosity agent. However, we still don't know how these mechanisms actually work in the agent systems. And another properties of UFOs make the studies more complex is the motive-based behavior. Like here are two examples show you the motive-based UFOs detected in the soft and hard X-ray bands, suggesting that the UFOs they have their intricate structure and making our theoretical predictions and observational explanations more complex. So that's all the properties and behaviors I would like to present to you today. Let's have a quick summary before we move on. The takeaway message of the UFOs in agents are UFOs are very extremely fast and powerful winds in agent, and they could interact with the accretion flows and could rapidly vary on both short and long-term time scales. However, it remains unknown how UFOs drives the agent feedback, although we know it's much related to their structure and the driving mechanisms. Then I will show you how the XRISM will revolutionize our understanding of UFO. Let me introduce XRISM first. XRISM is an X-ray mission led by Japan, United States, and also in collaboration with Europe. It was launched in September 7th of 2023, and there are two facilities on board XRISM. One is an X-ray CCD imager called X-band, and the other is the key facilities on this mission, which is called Resolve, which it is an X-ray microcalorimeter. And here is the here are the effective aerial and revolution power of Resolve compared with the other high resolution X-ray facilities, like the Chandra HETG and the XM Newton RGS. You can find that the Resolve could have the very much larger effective aerial than the other instruments, and it could provide the unprecedented spectral resolution in the hard X-ray bands. However, unfortunately, these curves were measured before the mission was launched. You know, when everything comes to the reality, some bad news maybe happens due to the technical issues related to the gate valve, which covers the Resolve. It cannot be successfully opened after launching. So that reduced the effective area of Resolve, reduced it to 1/1.6 in the hard X in the iron cable, as this blue line shows, and we cannot collect any photons below 2 keV. So it's a big pity, and since 2023, four attempts have been made to open it, but none of them succeeded. So it's very bad news, but even we have this issue with XRISM, XRISM still provides a lot of groundbreaking discoveries in the X-ray astrophysics. I will show you later. And here is the summary of the agent observed by XRISM during its performance verification PV phase. And each observation aims to study the different components of agent. For example, like the inner accretion flow could be well studied in the MCG 63015, and the jet could be well explored in the center of A in the high spectral resolution view to study it. And today I will focus on the XRISM observation on the prototype targets, prototype UFO targets in PDS 456. You have already heard this name, the name of this target many times in my previous slide. That's because this target is the Rosetta Stone in the UFO field. This is the most luminous radio quiet quasar in the local universe, hosting a supermassive black hole with a mass around 5 times 10 to 8 solar mass at the Agnon limit accretion. So as the right spectrum, CCD spectrum shows, the UFOs have been persistently detected in this target with exceptionally high significance over the 20 years. That makes this target very an ideal laboratory for the UFO studies, because if you remember, I mentioned the UFOs are very variable, and the persistent UFO detection is very valuable in this UFO study field. Furthermore, the outflows detected in the other wavelengths have already been reported in this target. The upper three panels shows you the outflows detected within the 1 parsec distance to the supermassive black hole. The ionized gas with a relativistic velocity have been reported in the hard X-ray, soft X-ray, and the ultraviolet spectrum. And at a larger scale, which means the galaxy scale, the outflows weakly ionized or the molecular gas with a velocity around several hundred kilometers per second have been reported in this target from the optical, infrared, and radio observations. So this allows us to explore the connections between the outflows in different wavelengths. So we could compare the outflow kinetic energy here, and this diagram shows you the y-axis is the momentum flux, and the x-axis is the outflow velocity. And the outflows detected in PDS 456 are marked by these solid and hollow red stars. And you can find they are the UFOs and molecular outflows detected in the targets, and they have a very comparable momentum flux, suggesting that the UFO in this target is likely to drive the momentum conserving outflow at the galactic scales. That's all. That's a brief introduction about the PDS 456. And for the XRISM, during its PV phase, it performed a very deep observation on this target, coordinated with several other space X-ray telescopes, as well as the ground-based optical telescopes. Here are the time coverage of these different facilities, which enables us to study, to have the complete picture of this target. And then here are the soft and hard X-ray light curves during our observation campaign, and it clearly showed an X-ray flare during the exposures, and this will be used for our later analysis. And when we look at the CCD spectrum on the right, the blue and cyan points corresponds to the observations in this campaign, and we can find in the soft X-ray band, which were below 2 keV, the targets were at the faintest state in the history. So that's limited the photon collection in the soft X-ray band, so that we cannot have a good soft X-ray high resolution spectrum in this campaign. But when we look at the hard X-ray band, the source is brighter than the average observations, and which is very good for the data quality from results. Then let's look at the high resolution spectrum of this target. Here are the residual spectrum of XRISM, XM, and NUSA against a very simple polar model, zooming the iron K band. And the rest of frame energy of the iron-25 and 26 line will marked by these vertical dashed blue lines. When we look at the outflow emission part, we find regardless of the instruments, the emission part is always smooth and broad. But when we look at the absorption part, in the conventional instrument, which means in the lower two panels, the UFO absorption feature is very broad and smooth. But when we look at the resolved spectrum, the broad absorption feature was resolved for the first time into multiple narrow lines. And the dispersion of this absorption feature is too broad, so that we cannot use the a single velocity component with different ionization state to explain this. So this multiple narrow absorption feature means these lines must come from the multi-velocity component. That's the groundbreaking discovery brought by the XRISM. And then we need to model these UFOs. We use the photonization code XR to model this, and the code highly depends on the spectral energy distribution called SED. So we use the optical monitor photometry data on board XM and plus the X3 CCD spectrum to constrain the SED of the target. And here the dotted black lines are the intrinsic SED we input for the photonization model. Then the right shows you the results of the photonization modeling for the absorption component. And we find at least 5 absorption UFO components are statistically required by the data. And the lower 5 panels shows you the transmission spectrum of each component. During the spectrum fitting, we link to avoid the parameter degeneracies. We link the ionization parameter and the turbulence velocity of each component together to leave the current density and the velocity to be free. And we obtain the average ionization parameter log C around 5, and the turbulence velocity around 2,000 kilometers per second. The current density of each component spans around 10 to 23 per centimeter square, and their velocities range from 23 to 33% speed of light. And the discovery of these 5 distinct absorption components means that the UFOs in PDS 456, they are not homogeneous and not smooth outflows, but they are highly inhomogeneous and clumping wing. As for the emission part, since we observe a very broad emission profile, such a broad emission profile must come from the photons with strong blue shifted and red shift. So when we model this profile, we not only use the XR emission model, but also convolve it with velocity profile from an outflowing hemispherical wind. And the plasma parameters were linked to the absorption components, and with only the opening angle to be free. So these red lines shows you the best fits of the model, and the results provide a the covering fraction to be the unit for the target. And that means the UFOs could fully cover the skies of the X-rays in PDS-456. And the right is a schematic plot for that velocity profile. So when we have all the spectroscopy results, we could use them to estimate the size and the locations of these UFO clumps. First of all, by combining the definition of ionization parameter and the current density, we could build a relationship between the clump size and the location. And then, taking advantage of the variability we observed during the campaign, we could use the variability time scale. If we assume it originates from the corona variation, we could use this to estimate the size of the hot corona. And since we observed the UFO absorption part could absorb photons in the hard X-ray bands with over 50% photons, that means their size should be comparable with the hot corona. So we could use this to set up the upper limit for the clump size. And then the other constraint could be derived from the less variable iron K emission during the whole observations, which is around 500 kilosecond. That we would expect the outflow location is larger than the light traveling distance during this period. So that will set up the lower limit for the clump location. So by combining these three conditions, we could determine the size of the clumps between 2 to 16 gravitational radii and the distance between 200 to 600 gravitational radii. Then we could use them to estimate the kinetic energy of outflow. Yeah, the remaining unknown parameter in this mass loss rate formula is the volume filling factor. We could take the fact that we observed 5 UFO layers to derive it. First of all, this multiplicity is defined by the total 2D surface area of clumps over the spherical surface area of the outflows. And it must equal to 5. We could use this to determine the total number of the clumps, which is between 10 to 5 to 10 to 6. And then the volume filling factor is defined by the total volume of the clumps over the volume occupied by the outflows. Then we could derive it between 0.1 to 0.3. Then the mass loss rate is estimated between 60 and 300 solar mass per year, which is comparable with what we observed in the molecular gas. And the kinetic energy is very powerful, approaching to the ideal luminosity. That means the U, which is way much higher than the threshold. If you remember, it's just the 0.5% ideal luminosity. So that means the UFO in PDS-456, they are powerful enough to affect the co-evolution of black holes and galaxies. So that's all the inference from the XRISM observations. But what's new? In fact, compared with the previous results, the UFO plasma parameters were very comparable, consistent between what we derived from the XRISM and what we derived from the CCD spectrum. But what's the difference? Here, in the past, the mass loss rate we derived from the CCD spectrum was just around 10 solar mass per year. That's because we thought UFOs are homogeneous and smooth outflows. So the integral of the current density starts from the inner radius of the outflow launching radius to the infinity. But XRISM told us, no, this is not true. So UFOs are clumping with outflows. So this integration range is finite. that means for the comparable current density, the materials are confined to smaller regions, which will enlarge the mass loss rate, which will increase the mass loss rate. So that's a revolutionary understanding brought by the XRISM. And yeah, then we can report that the previous momentum flux versus the outflow velocity diagram again. And then you will find the outflows detected in the X-ray bands are much more powerful than those we observed in the molecular gas. And they are also inconsistent with both energy or momentum conserving outflows. How can we explain this inconsistency? Two possibilities were proposed. First, probably the UFOs were episodically launched over the quasar lifetime. According to the momentum difference, we expect maybe the UFOs activity period only occupy less than 10% over the quasar evolution. Another possibility is the energy transfer between the wings and interstellar mediums may not be efficient because both of them have the very inhomogeneous structures, so that their collisions are not very effective, so which will limit the energy transfer between them. So both of them could account for this inconsistency, but we still don't know which one is correct, and we need more observations and more detailed simulations to understand this. That's all the results I would like to present about the PDS 456 today, but this is not the end of the story, because I would like to take this opportunity to show you more fantastic results from XRISM related to the agent UFO. So I will spend several minutes to give a brief introduction to the other XRISM observations related to UFOs. So a natural question following the PDS 456 is PDS 456 unique to host a UFO forest? The answer is no, because here is the XRISM GO1's observation on another nearby bright quasar, and PG 1211. We could also detect a series of UFO absorption components, and in this case, the RGS also bright, so we could also detect the multiple UFO components in the RGS spectrum. That means the clumping. That means the UFOs and the nature of UFO is clumpy. That confirms our discovery in PDS 456. And another interesting target is a PD spectrum of RS 05189. At the first place of this resolved spectrum, you may not find, besides of the UFO forest, you may not find anything new unless you know this target is an ultraluminous infrared galaxy, which is at the late stage of the galaxy merger. This is the short life stage for the during the galaxy evolution, and very crucial for us to understand the evolution of galaxies. So we are talking about the physics between the starburst phase and the quasar phase of galaxies. And the discovery of the UFOs in this target means that the powerful winds have already been developed in the precursor stage of quasars, and they are about to suppress the star formation rates and drive the system involved towards the quasar phase. Again, the momentum, flux, and kinetic energy of these outflows succeeded what we observed in the molecular gas. So now the question is no longer whether UFOs are powerful enough to drive the agent feedback, but rather how their energy could be transferred and dissipated during the propagation. The last slide before the conclusion is about the black hole Southern Star in NGC 4151. 6 wind absorption components were detected in the resolved spectrum with a velocity ranging from hundreds kilometers per second to tens or hundreds of thousands kilometers per second. And so the kinetic energy of the higher velocity wind component is also powerful enough to drive the agent feedback. What makes this target particularly intriguing is its multi-messenger nature, because NGC 4151 is one of the nearest agent known as a gamma ray emitter and the potential source for the neutrino emission. In fact, together with NGC 1068, this is one of the 2 strongest candidates for persistent neutrino emission. So that maybe has some physical connection between the inner accretion structure, launch of the outflows, and the acceleration of these high energy particles, such as the neutrinos and cosmic rays. So that's all fantastic results were brought by the XRISM. So that's the end of my today's talk. I will leave you with this summary. And the message I would like to take away is XRISM has opened the area of the high-resolution hard-active spectroscopy, and UFOs are not homogeneous outflows but clumpy winds. And they are very powerful enough to drive the agent feedback, but we still don't know how the power transferred into large scales. That's all about my today's talk. Thank you for your attention, and I'm glad to be here for the questions. Thank you.
Thank you very much. Questions?
This source, you said there are 2 possible mechanisms to drive the winds. One is the radiation driven or the field driven. So the target to come out of spherical wind, which one favors?
Yeah, thanks for the very nice question, but yeah, I didn't show here. First, the answer is we're still quite not sure, but we prefer the radiation-driven outflow. The reason why there's several evidence. I don't know if I can show you in the first of all, this result was about PDF 456, come from CCD observations. We find the variability by studying the UFO velocities across two decades, and we could find the hard X-ray luminosity is correlated with the UFO velocity, which suggesting that the UFO is driven by the radiation field. And also another evidence, which is from my work, but I don't have, but it have too many technical details, so I didn't show here. If you remember, we linked the ionization parameter between different components during the fit, but actually this is not realistic because since we observe 5 absorbers aligned with our light site, each one may affect SED for the outer absorbers. So I used a more detailed analysis to study the relative position between different components, and that's what I find. Yeah. Sorry, I didn't show this because I don't have time. Yeah, it has a stratified distribution in the outflow velocity and versus the ionization parameter diagram, and you can see the results. We use the more realistic analysis are marked by these red triangles, and they are stratified. But if we just assume the same SED for different components, as these blue and the green point shows, they are randomly distributed. So first, the outflows in the target could have the stratified structure, but when we compare these slope index, we find it's inconsistent with both radiation and also the magnetic-driven outflows. It's very complex. And the third evidence to say we cannot give a very conclusive answer is when we estimate the momentum flux of the UFOs compared with the relative momentum flux, we find the relative momentum flux is 1 order of magnitude lower than the outflow momentum flux, which means driving the outflows purely by the radiation pressure is very difficult. Probably we will have some contributions from the magnetic field lines. So probably they could be a combination, but that's the interesting question. Yes, thanks for asking this question, but I cannot give you a very conclusive answer.
So thanks for the comment. I'm doing transformation for me, so this creation and output transformation very similar to what you have featured here, but the scales are very different. And one of the things is that, so we expect that when there is a lot of accretion, we have a lot of outflow activity. And then in the first part of the talk, I don't know if I get got it wrong, this is why we were comparing the luminosity of the brightness at smaller scale, that is less than 10 RG, compared with the intensity of the UFO or and I think there was some anti-correlation. So the brightest the smaller scales were, which to me I understand that higher the accretion is exactly. Yeah. So I would have expected the opposite. So if you have more accretion, you will have also more outflow activity.
Yeah, thank you for the question. Yeah, you're right. More accretion, we will have more outflows. That's why I mentioned the radiation-driven explanation, because we would expect UFOs in the high accretion system. That's what's your point. But here, that's a difference because here are the hard X-ray spectrum luminosity. So the hard X-ray are very hot, and the UFOs here are also very highly ionized, which means if we have more hard X-ray photons, the UFOs will be over-ionized. That means we cannot observe very strong outflow features. So that's why it could explain this anti-correlation.
Yeah, thanks for the question.
Yeah.
More questions? Well, I have one question.
Yeah.
You said that the UFOs and warm absorbers, they are probably like in the same system, but different scales.
Yeah.
When you have an UFO that has a variability, so disappears, you cannot detect it. Can you detect the WA region? So they can move from one to another?
Yeah, it's very difficult because UFO, we know it has a very strong variability, but warm absorbers, they are usually very stable because they are at the larger scales, and it's very difficult to expect its response very quickly. Also because of its lower density, they cannot respond to any unless it has very large continuous variations. So, the recombination time scale is inversely proportional to the number density of the outflow. So, which means for the warm absorbers, they have a lower number density, so they will have a longer recombination time scales. So even if we find some X-ray variation, we observe some X-ray variations, but due to the longer recombination timescales, we cannot well constrain all the detected variations. No, that's why I said we still don't know, if they are related, because we didn't have some observational evidence. Yeah.
Thank you. More questions? No? And online? Can you check?
Yes. Hi.
Yeah.
Okay. Well, my question is, one of the challenges when studying AGN feedback is the time scales. For normal outflows, the AGN feedback produce maybe observed once the AGN is turned off. So my question is, being UFOs much more energetic and with that time scale variability of such powerful events, it is possible to see a more immediate impact in the host galaxy.
Sorry, I didn't understand your question. Can you?
Yeah, I mean, the UFOs are much more energetic than normal outflows. So for normal outflows, the AGN feedback may be observed once the AGN is turned off for the different time scales. So as UFOs are much more energetic and with that time scale variability for the events of the UFO, it is possible to see a more immediate impact in the host galaxy. The AGN feedback is more immediate, or the time scales are also very large.
Yeah, the time scale is very large. If we want to, yeah, that's still an open question. So because the UFO launched from the very inner region, so I didn't estimate how long it will take for the UFOs to transfer from the inner to the galaxy scale. So yeah, I don't, I'm not quite sure. What we usually investigate is to compare the UFO energy and then compare it with the large scale outflows to, if we assume they have some correlation, and to see if it could be possible driven by the UFOs. Yeah.
Okay.
I hope I answer your question. I don't know.
No, yes, this is a very open question. So that was, I didn't know about UFO variability. So that'd be very interesting. And I thought about this question. Yeah. Thank you.
More questions online? No? Okay, so let's send again.
Sorry, the last one is to just introduce myself. Like, my office is at the second floor of 18, which is next to the canteen. So, wait, I have it. Okay, let's get started. Sorry. Yeah, my office is next to the cafeteria. So if you have any questions and would like to discuss with me, you can just knock the door. Yeah, that's all. Thank you.
So because that's